Welcome to another episode of CUDA Education. Today I need to continue our conversation on vkCmdDrawIndexedIndirect. So in my research, I have learned that this function is actually a big deal. It's a relatively new feature in the computer graphics world. Or at least it's a big deal, one of the two. But the thing about it, the ability to control what you draw directly from the GPU and not have to sort of go back and forth and be in conversation with the CPU is actually a really big deal. And it's a big deal because it affords massive performance gains. All right. So I need to spend more time discussing this function. I thought I was kind of done with it, but this gets way deeper than I initially anticipated. And it's only right that I spend more time with it. All right. So the first big picture thing that I want to discuss is the fact that again, we test for the multiDrawIndirect feature, right? And if our GPU for whatever reason doesn't have this multiDrawIndirect feature where we submit one command, this vkCmdDrawIndexedIndirect, and all of our draws are basically done, right? All of our draws are done with that one command, right? If we and notice also again, notice how many objects are in play here. 31,000 whatever, right? So this is not trivial. This is not a trivial thing, right? So if we have the feature, we submit one command, right? Now this command, of course, is in build graphics command buffer, right? So we're talking about the command buffer in our application, and we either submit one command if we have the feature, but if we don't have this multiDrawIndirect feature, then we have to submit one command for each object, right? And this is a huge deal because, as you said, we saw 30,000 objects, right? So you literally have to submit this vkCmdDrawIndexedIndirect 30,000 plus times, loop over each object and submit it 30,000 plus times, because we don't have this ability to submit one command and have everything processed or understood or known to be processed with this one command. Now, of course, when we submit this vkCmdDrawIndexedIndirect, of course, the GPU internally has to loop through all of the stuff in the has to loop through all of the items in the buffer, in the GPU side buffer, to actually render the objects, right? So understand that yes, we submitted one time here, but then the GPU internally has to loop through it each time. Here, we're submitting this function 30 plus thousand times, and where every time we submit, we're only drawing one object, right? We're only drawing one object, right? And we know that because the second to last parameter, which we'll get to, the second to last parameter The second to last parameter is the draw count, right? So here the draw count is 1. Here the draw count for when we're looping through all 30,000, we're submitting every time we have to submit this thing, we're only getting 1 draw, okay? And there's a cost to submitting this function every time we do this call, right? So there's a cost here, and we're only doing 1 draw. So that is why in the previous video we saw that there was this CPU stutter, okay? There was this CPU stutter because we're calling this function 30,000 times, and each time we call it, we're only doing 1 draw. If we have the multiDrawIndirect, we submit this function 1 time, we hit it 1 time, and we get our 30,000 draws basically looped through and managed on the GPU, right? And we know we get our 30,000 calls because we're doing, it's not just 1 draw call as a second to last parameter. It's the size of indirect commands, which is, which is the size of all possible, the maximum number of draw calls that we could possibly draw, right? So this is the upper threshold, right? So we already have a container for the maximum number of draw calls, and we basically we just hit this function 1 time. Notice that there's no for loop here. It's just 1 command. There's no for loop. Now in the else part, when we do the fallback, there is a for loop, and that's where the nightmare starts, right? So here we don't have a for loop. We just have 1 call, and the size of the maximum number of draw calls is included in our draw count, and we're good to go. All right. So this conversation, I sort of referred to it in the previous video, but now we want to go a step deeper. All right. So vkCmdDrawIndexedIndirect. We know we're talking about a draw function. Okay, vkCmdDraw, that's like the most basic function. vkCmdDraw is that we know we're asking Vulkan to draw something. Pretty understandable, right? We're doing indexed, right, because we have our indices, right? And let me see. Let me see if we have our notes, right? So we have our notes, right? And we're doing indices again, right? So we're doing indices. We're not just doing the thing, we're doing indices, and we can repeat the indices and all that, and it makes our situation efficient, right? So we get the index. That's what the indexed part refers to. And then we're doing indirect because we're basically managing the draws, the draw calls, what we decide to draw from the GPU itself. We're not necessarily going back and forth. We're not in conversation with the CPU. We're doing it directly on the GPU or by means of the GPU, because we are manipulating the buffer that decides what is drawn, right? So the GPU is directly going into the buffer and saying, hey, turn off these objects, turn on these objects, and that's what we render, right? And we could see that when we do our thing here, because right now we have all this stuff, right? But if we freeze Frustrum, right, and then we remove things, right? We're removing things and we're only showing what's in our screen. That's the GPU is going directly into memory and turning on and off for each object, whether to draw it or not, right? With the instance count 0 or 1, the instance toggle, right? And of course, if we unfreeze the Frustrum, we're now drawing everything again. And again, this is being done by the GPU because we're turning on all these objects, okay? We have investigated that many a times because of this the compute shader, cull.comp, right? The compute shader, and we have instance count of 1 if we decide to draw, and instance count of 0 if we decide not to draw, right? Let's not get into this. You know, we've covered this many a times. All right, so the thing is, again, we're submitting one command, and we're putting the maximum number of possible draws as the size of the draw count. Okay, so you guys have to kind of follow me now because I want to get into get into more detail with this. All right, so we have our vkCmdDrawIndexedIndirect. vkCmdDraw is to draw the triangle draw, just a basic draw call in Vulkan. Indexed means we're using indices, so we're not using vertices necessarily. We're referring to indices, which is just labels on the vertices, and then we could reuse those labels, and the labels are more efficiently easier to manage. It's less memory burden and all that stuff. And then we have our indirect because we're doing GPU based drawing. Like we're basically manipulating and deciding what we draw directly from the GPU. We're not into any real conversation with the CPU, which is performance gains. Okay, so what we have to do now is we have to let us spend some time and investigating the signature of the vkCmdDrawIndexedIndirect, and here is the signature. Okay. So the signature has this as its okay. All right. The signature has this as its parameters, right? Actually, I wanted to go here. Right, the signature has this as its parameters. It has a command buffer, which is what we're building. Has a command buffer. It has command buffer is the command buffer into which the command is recorded. So I'm not gonna spend too much time with this right now. Then we have as the next parameter the buffer, right? So we have the command buffer, then we have the buffer, right? And this is the buffer is the buffer containing draw parameters. Okay, so this contains our draw parameters. This is what everything hinges on. Okay, because in this buffer is what we decide what is going to be drawn or not. And we decide that because we have our instance count of 1 or 0, right? So basically all the toggles and all the decisions that are being made are being basically baked into this buffer right here. Again, we said that the GPU is going into the buffer and turning on and off objects that we want to draw or we don't want to draw, right? So this is at the heart of this indirect piece of it. Okay, fine. The next parameter is the offset. The offset is 0. We're not going to get into that. The draw count now is the size of indirect commands. Okay, but notice that this indirect commands, this structure, this object here that we're using is different from this guy right here. I will get into that into a second. I promise I will get into it. But just notice that now we're doing the size of indirect commands. And what it represents is a maximum number of possible draw calls, right? I will elaborate more in a second, but let me just get through the signature and the parameters. And then we have our stride, right? The stride is just basically what we do to go to the next thing, right? I don't want to too much get involved in this too much right now, right? what I want to focus on is we have our instructions with indirect command buffers, and we have the size of all possible draw calls with indirect commands. These are two different things. Indirect command buffers and indirect commands is two different things. All right? How are they different? What are they what is it different? The indirect commands is the CPU side. Okay? So the indirect commands is the CPU side. It's sort of a, let's just keep it at that. The indirect commands is the CPU side. The indirect commands buffers is the GPU side. Okay, so CPU side, GPU side. Now they're almost like siblings. They're like first cousins. They're very similar. They're almost like twins. Almost. They're almost like twins. Okay, in terms of their structure, identical twins, not non-identical, identical twins. Okay, so we have our indirect commands and we have our indirect commands buffers. Okay, indirect commands is CPU side. Indirect command buffers is the GPU side. The heart of this function call right here is the indirect commands buffers, because this is being manipulated by the GPU. The data inside of it is being manipulated by the GPU to decide what is being drawn and what is not being drawn. The indirect commands object, which is the CPU side, it's just a dummy object. All right? Pause. We have to pause right here. Why are we creating a dummy object? The reason this indirect commands exists is to, it basically is to initialize everything and to figure out what's the maximum number of what are the limits of the draws that we need, right? What's the maximum number of draws that we had? So if we turned on all the objects and we decided that we wanted to draw all the objects, what is that number, right? This is what indirect commands is doing. It's mimicking the indirect commands buffers. It's mimicking the object on the GPU side, but it's turning on everything, and it's saying, okay, guys, we're gonna initialize everything, and we're gonna put the maximum. We're gonna put the maximum. We're gonna put the scaffolding, right? Think of it like if you had a balloon. Okay, it's your birthday, and you're blowing up a balloon, and you're creating like a tent, right? A tent that is supposed to be, everyone is underneath this tent, and this balloon is your birthday balloon with your name on it, whatever. And you're gonna blow up this balloon. Well, you need to know what is the maximum size that this balloon is going to be, right? You need to know the maximum size of this balloon, because you don't want the balloon to be bigger than the tent. Okay, the balloon is supposed to be inside the tent. All your guests and friends are going to be inside the tent. You don't want the balloon to be bigger than your tent. So what this indirect commands is, the CPU side structure it's just a dummy. It's a dummy entity that basically says, okay, I need to know what's the maximum size. How big of a tent do I need to accommodate this balloon that's going to be, expanding, right? What's the maximum size of the balloon, and how big of a tent do I need to house that balloon? It's the same thing here. This indirect commands thing for the CPU side, all it is, it's a dummy structure that helps us to figure out, what is this? The draw count is the number of draws to execute and can be 0, right? So if we look back at our signature, we see that the second to last parameter is draw count. Okay, so for here, the draw count is basically indirect commands, which is our dummy function that decides what's the maximum number of draws that we could call, right? Let us just hang out here for a second. So again, if we run our function just as it is, we get this. Okay, Now, word on the street is draw count is the number of draws to execute and can be 0, right? So word on the street is this can be 0, okay? So what I'm going to do is I'm going to make this 0, right? So now I make this 0. And hopefully nothing blows up. Okay, so if I make this 0 and we rerun, everything runs as need be, but notice that we do not see anything. Why don't we see anything? We don't see anything anywhere. Now this is being done computationally, so it's still, as far as the computation is concerned, these things are valid objects or whatever, but we are not drawing anything. There's nothing being drawn. Why is nothing being drawn? Nothing is being drawn because the draw count has been set to 0. Now if I go put it back and we run it again, now we are going to get back our objects. Okay, we get back our objects, right? Now here's the fun part. Let's say we do 10,000 objects, right? So it's going to be like a third of what is normally supposed to be drawn, right? We do a third. We just get this thing right here, which is not that much. It's like a wafer, right? It's just a wafer, right? And notice how, okay, this is a very important teaching point. In one of my videos before, I talked about how the camera is like, it's not a flat, it's not a flat plane, but it says rays shooting from a point equidistant is a sphere. So think of the camera as a sphere. So as we get closer, notice that the middle lights up because the sphere, the very tip of the shortest distance between 2 points is a straight line. So the very front of the camera is changing color because the distance test is saying, hey, this is closer than all of these guys over here. But as we get closer, notice that our sphere is now eating into more objects, so we get a change in color. But I digress. Okay, so we did 10,000 objects. If we just do 1,000 objects, right, and we set our draw count to 1,000 objects, we will get even less objects, right? And if we do 100 objects, we get even less stuff. We get even less stuff, right? And yeah, okay. So we understand the draw count conversation, right? But we are submitting the whole pie of all possible objects here. So our maximum value is that. Now what we actually choose to draw is either going to be the maximum number of objects or it's going to be smaller than that, right? Which is fine. So we have our draw count. The stride we're not going to get into too much. The offset we're not going to get into. We have our indirect commands buffers, which is the GPU side. So notice that we're talking about the GPU side now. And we have the command buffer. Let me just real quickly, just for completeness, actually, yeah, let's not. But anyway, this is the command buffer. Okay, so we're building the command buffer and we're saying, hey, we're doing a bunch of stuff for the command buffer. And we draw here. And then, yeah, kind of notice that this is the last thing that we do because we're doing a bunch of stuff with the command buffer variable, and then this is like drawing the UI and stuff, but that's different. Okay, so yeah, let's not digress. Okay, so let us just investigate this indirect commands variable. Okay, so the indirect commands, go to definition. Store the indirect draw commands containing index offset and instance count per object. Okay, so vkDrawIndexedIndirect command. It's a vector, right? But what I want to do is, where does it define? Okay. So object count, object count, object count. So this is where we basically decide how many objects we're doing. So we're at 245, right? So yeah, this guy right here, total number of objects in the scene, right? So 245. Okay. So we're basically we have our dummy index commands and then indirect commands variable, and then we resize it to basically say, okay, the maximum number of objects that we could be drawing is object count times object count times object count, which is in the variable object count, and then we resize indirect commands to the size of the object count, right? And we also default all of them. This kind of doesn't matter, but we also default the index. The tongue twister, guys. There's so much. We default the instance count inside of indirect commands. We default the index count to 1. So we're turning on all the objects. But it really doesn't matter. It doesn't matter because the compute shader is going to decide ultimately, the compute shader is ultimately going to decide what to display or not, right? But I guess just for completeness, it turns on all of it initializes it to 1, and we'll just leave that at that. And then we do some other stuff, but basically we're filling in all of the attributes of the indirect commands variable, okay? And yeah. And we're actually creating the buffer. And I think this is just a staging buffer. Yeah, because we have to basically move it over to the GPU. So we're creating, we have indirect commands on the CPU side, and then we do a staging buffer thing to initialize the indirect commands buffers, which is on the GPU side. Okay, but this is going to be a different beast because this is going to be on the GPU, and it's gonna change stuff or whatever. But we initialize on CPU, and then we get the cousin, the twin, on the GPU side, right? So that's what that is, which we're not going to get into right now. All right, copy buffer, all of that stuff, right? And yeah, we're not going to get into sync right now. We're not going to get into sync. Oh, we're not worried about that right now. Yeah, okay, so we have our indirect commands. Hold on. You see, that's the thing, that's the thing. Right, so we fill in the indirect commands. I just want to make sure that I didn't, Yeah, this is the other variable, so we're not. One more time. Let me just. Okay. I just want to make sure I'm not missing anything that's important. That's all. Right. Okay. So right. So that's pretty much for this function. That's all this indirect commands does. Is we need it to be a placeholder to figure out what's the size of the maximum number of draw calls, right? Then now let us go to indirect commands buffers, right? Now indirect commands buffers is the GPU side, right? Now this is going to get really interesting because I want to see on the call. Yeah, let's not get into that. So indirect commands buffers. Let us go through that. All right, so we'll start from the beginning. All right, so we have indirect commands buffers contains the indirect drawing commands. Okay, so it's a buffer and basically it's the GPU side and it is what is directly manipulated in order to decide what we need to do on the drawing of the application of the objects. Okay, I might have to elaborate more on this in another video, but we do have our GPU side. This second parameter is buffer is the buffer containing draw parameters, right? So this is going to hold our draw parameters. Okay. Yeah, we'll have to talk about this another time. Um, but I did want to just have you guys appreciate exactly what's going on with this function, right? But yeah, this gets more involved. But just understand again, guys, that the indirect commands buffer is the GPU side buffer, and this indirect commands is just CPU side. It's just CPU side scaffolding. It's almost like your whole playbook, right? So you might not necessarily use all the plays in a game, but you need all your options, all your playbook, all the options possible for your team. So you have this playbook, okay? We'll have to investigate this further another time, but this is vkCmdDrawIndexedIndirect. Now, I did want to briefly contrast this with vkCmdDrawIndexed, okay? So let us just quickly contrast this with vkCmdDrawIndexed, okay? So vkCmdDrawIndexed versus vkCmdDrawIndexedIndirect. We are doing a draw and we are using indices. We are doing a draw and we're also using indices. The difference here is that we're not doing indirect, we're not using the GPU to issue or manage the draw calls. We don't have that ability here. So vkCmdDrawIndexed is just, we're doing a draw call with indices and that's it. Notice that there's a whole bunch of stuff: command buffer, index count, instance count, first index, vertex offset, first. That's all mechanical technicalities dealing with, vertices and indices, or dealing with indices and reading the data and stuff. But the biggest thing that you have to appreciate is that there is no buffer. So this second buffer thing in vkCmdIndexedIndirect, the second buffer is the buffer containing draw parameters. Notice for vkCmdIndexed, you don't have that parameter, right? And the reason you don't have that parameter is because you're not trying to use the GPU to issue the draw calls. The draw calls are just basically being issued, from the CPU, organically, right? But when we have our indirect, we're now dealing with, we have to declare a buffer that the GPU is going to manipulate to decide what is being rendered on the screen. Okay. At some point, I will get into what this buffer, we'll dive deeper into this buffer variable, which is this guy here. Okay. And, we'll get more involved in that. But yeah, so now you guys understand vkCmdDrawIndexedIndirect and vkCmdDrawIndexed, where we don't have the indirect piece, because which means we don't have to declare a buffer that's on the GPU side that manipulates the decision of what is being drawn. Okay, we also kind of went over the stutter thing. The thing with the stutter is that if we have 30,000 objects, we're making this call 30,000 times, which is a lot of driver overhead, a lot of inefficiencies. And every time we call this, we're only doing one draw, right? Whereas if we have the multiDrawIndirect, we do one vkCmdDrawIndexedIndirect, one call, and then we get 30,000 objects. Internally, the GPU will go through all of the objects and decide what to draw or not. But there's no back and forth. There's no back and forth. Because remember, this for loop is actually on the CPU, right? This for loop is on the CPU. So every time after you do a draw, you're returning back to the CPU, and the CPU is issuing another vkCmdDrawIndexedIndirect, right? and then it does its thing. Here, we do one call, and then all of the draws are implicitly being decided and rendered based on what's in the buffer. Okay? Anyway, guys, this is CUDA education. If you want to be able to follow along with this stuff, you need to get a Windows machine with a Vulkan-capable GPU, so that you can be able to run these examples. This example is not ray tracing capable, so if your GPU is not ray tracing capable, you're still good. But if you want to be able to run the ray tracing examples, you need an RTX GPU from NVIDIA. I can't talk about Intel and AMD. Anyway, guys, thank you for watching. Have a great day.